The number of new dinosaur species discovered in recent years has increased exponentially. But what if new research actually reduced the biodiversity, combining branches of the tree of life? Late Cretaceous dinosaurs, such as Stegoceras validum and Ornithophilus browni, were originally thought to be separate, but researchers have found that they are actually members of the same species, and that Ornithophilus browni is in fact a juvenile Stegoceras. How can we determine that these different-looking skulls came from the same species? We can line up the skull fossils into a growth series, from juvenile to adult, showing a clear progression based on conserved morphologies, traits that we see in all the skulls, even as extreme growth occurs. It's clear that the skull doesn't grow in all dimensions equally or isometrically, but instead, the proportions change as the skull grows. This is allometric growth. We analyze major skull features, determining statistically if their growth follows predictable trends. How can we be certain that Ornithophilus is a young Stegoceras, and not just a closely related species? For this, we turn to paleohistology, studying the microscopic structure of bone, which describes an animal's age, growth rate, and relation to other species. Dinosaurs and other vertebrates have bone containing zones that are dense and zones that are porous, with many vascular canals, passageways for blood vessels, nerves, lymphatic vessels, and connective tissue. More nourishment means more bone growth can be supported. Bone-building cells, called osteoblasts, create new bone quickly on the outer periosteal surface of the bone, forming features like the dome, but also lay down bone at a slower rate on the walls of the vascular canals. Over time, this vascular space constricts, and bone growth diminishes in that region. High-resolution CT scans show us that the flat-headed skulls, including Ornithophilus, have more porous, vascular bone, so they can support fast growth, indicating that they are in fact juvenile. The older skulls have denser, less vascular bone. These three lines of evidence, conserved morphology, allometric growth, and paleohistology, allow us to conclude that Ornithophilus is actually a juvenile Stegoceras. Researchers are combining several species using these methods. How many more species are waiting to be regrouped and reorganized? Our investigation of the vast history of life on Earth continues.